Hello learners, welcome to my YouTube channel Math Chem Mystery. Today we have Chemistry Form 3 lesson 3. In the previous lesson, that is lesson 2, we have talked about the definition of the Charles law, molecular explanation of the Charles law, the graphs of the Charles law, implication of the Charles law, mathematical expression of the Charles law, temperature interconversion. That is the last thing that we have discussed in that lesson. Lesson 3, today here we have application question of the Charles law. Still we are discussing Charles law. We have the application questions of the Charles law. Now let's see question 1. This is the first question that we have. We have a certain gas occupies a volume of 25 centimeter cubic at temperature of 50 degrees Celsius. Always remember the Charles law. We say we have two variables that affect only. It is the volume and the absolute temperature. We talk about now the temperature. Those are the two variables that affect the Charles law. We say the pressure in Charles law is constant. So here we have a volume, so which is 25. Let's say this is a volume 1, which is 25 centimeter cubic. Then a temperature, that is temperature 1, which is 50 degrees Celsius. Always the temperature in Charles law, it is expressed in Kelvin. So let's change this 50 to Kelvin. So we add with the 273. To change from degrees Celsius to Kelvin, you add 273. So we add 273 here, which is how much? You have a calculator. We add now 50 with the 273, which is 323. So we have 323 Kelvin. What volume occupied by the same gas? So what volume? So meaning we have volume 2. It is what? We don't have. That is the volume that we need to calculate. At what temperature? At temperature of 75 degrees. Meaning temperature 2, it is 75 degrees Celsius. The temperature in Charles law, it is expressed in Kelvin. To change from degrees Celsius to Kelvin, you add 273. So we had 75, we add 273. What do we have? We have 75 plus 273, which is 348. So we have 348 Kelvin. Let's do our calculation. The formula for Charles law, we said it is V1 over T1 equal to V2 over T2. Our V1 here is 25 over V2 here is 323. The temperature that we take is supposed to be in Kelvin. Temperature 2 V2 is the temperature that the volume that we're calculating. Temperature 2, we have 348. From here we do what? We cross multiply. 323 times V2, we have 323 V2 is equal to 25 times 348. So what are you going to have here? Is 323 V2 is equal to what? We have 25 times 348. 340, that is 25 times 348, which is 8,700. We have 8,700. Can we get V2 here? Yes, we can get. We divide here 323 and we divide here 323. So V2 we have what? We divide 8,000 with 323, which is 26.9, roughly 26.9 centimeter cubic, and that is the volume that the question asks to calculate. So let's see here. Our volume 1 here is 25, but the volume 1 here is 26. Why? Always from the question that you have, you can get the volume that you have, or you can show, or you can foreshadow the volume that you have. How? By doing now the temperature, because the implication for the Charles law says as the volume increases, also the temperature increases. So the temperature here is 50, increased from 50 to 75. So if the temperature increased, we expect also the volume to increase. So our volume was 25 and here is 26. Let's go to question 2. We have question 2 here. A sample of gas R occupies a volume of 240. That is volume 1. We have 240 centimeter cubic. At temperature of 30, meaning temperature 1, we have 30 degrees. So always the temperature in Charles law is expressed as Kelvin. So here we have 30. We change from this 30 to where? To Kelvin. So to change from degrees Celsius to Kelvin, you add 273. So we have 30, you add 273 is equal to how much? So we have 30 plus 273, which is 303. So we have 303 Kelvin. Let's go to volume 2. What volume will the gas occupy? That is volume 2. We don't have. At temperature of what? That is temperature 2. At temperature of 60 degrees Celsius. 60 degrees Celsius. The temperature in Charles law always is expressed as Kelvin. So here we have degrees. To change from degrees to Kelvin, you add 273. So we add here 273. So what are you going to have? 60 plus 273, which is 333 Kelvin. 333 Kelvin. So for us to solve now the question, we remember now the formula. What is the formula for the Charles law? Because it's the formula that help you to get the unknown values. So Charles law says V1 over T1 equal to V2 over T2. So V1 we have 240. We have 240 over T1. We have 303 equal to V2. What we are calculating over T2, 333. From here we cross multiply. 303 times V2. We have 303 V2 equal to what? 240 times 333. So what can we get from here? Let's say we have 303 V2 equal to what? 240. You have 240 times 333, which is 79,920. 79,920. Can we get V2? We divide here 303. We divide with the 303. So V2 is how much? That's also that we have 79,200 divided by 303. So what are you going to have? Volume 2, it is 263.76 centimeter cubic centimeter. And that is volume 2. Can we get the implication of the Charles law? Yes. The temperature was 30. It has increased to 60. If the temperature increases, what we expect for Charles law, also the volume to increase. The volume is 240. It has increased to 263. And that is now the implication of the Charles law that we have seen in the previous lesson. That is lesson 2. Hi, let's go to question 3. We have a question 3 here. A gas occupies 75 centimeter cubic. So we have a gas, that is volume 1. It occupies 75 centimeter cubic. At temperature of what? Temperature 1, which is 25 degrees Celsius. Always the temperature in Charles law is expressed in Kelvin. So to change from degrees Celsius to Kelvin, we add 273. So we have 25 with the 273. We'll be able to lead B. So we have 25 plus 273, which is 298 Kelvin. So we have 298 Kelvin. At what temperature will the same gas occupy at volume about 30? Meaning volume 2 we have, which is 30 centimeter cubic. At what temperature will it occupy? That is temperature 2. What we need to calculate there. So to express now calculation in the Charles law, we use now the formula. So formula says V1 over T1 equal to V2 over T2. Our V1 here is 75. We have 75 over T1. We have 298 equal to V2. We have 30 over T2. What we are calculating. So from here we cross multiply. 75 times T2. We have 75 T2 equal to 298 times 30. 298 times 30. From here what are we going to have? We have 75 T2 equal to 298 times 30, which is 8,940. 8,940. Can we get T2 here? Over 75 over 75. By 75. T2 we have what? We divide with 70, which we have 119.2 Kelvin. Meaning the temperature that we use here, it is Kelvin. If we want to change this Kelvin to degrees Celsius, always from Kelvin to degrees Celsius, you subtract 273. We can have 119.2 minus 273. What are you going to have? Minus 273, which is negative 153. Negative 153.8 degrees Celsius. And that is our calculation that we have. So let's see now the implication of the Charles law. Charles law, if the volume increases, the temperature increases. If the volume decreases, the temperature will decrease automatically. Let's say from this one, the volume is 75 and here it is 30, meaning the volume has decreased from 75 to 30. If the volume decreased, what do we expect for the temperature? Also the temperature to decrease. Let's look here. Our temperature is 298, it has decreased to 119. Or it is 25 degrees Celsius, it has decreased to negative 153.8 degrees Celsius. And that is now the question of Charles law. How do you apply the formula that you have to calculate or to solve problem for the Charles law? Here I have self-trial questions. So try to do this question. That is, I have 3 questions here. So that is question 1, question 2, and question 3. Try to do those questions and share the answer in the comment section. Thank you. Make sure you subscribe to our channel, you share, comment and like. Share to your friends, please.